All right, so you did it. You've spent countless hours training, tuning, and perfecting your machine learning model. It's sitting right there in your notebook, performing beautifully, and honestly, that's a massive achievement. But it's also where the real challenge is just getting started. Because the huge question looming over everything is, now what? I mean, how do you take that brilliant piece of research and turn it into something that can actually handle the pressures of the real world? This, right here, is the gap between a cool idea and a great product.
See, in production, it's not enough for your model to just be accurate. It needs to be fast, right? That's low latency. It has to handle maybe thousands of requests all at once. That's high throughput. And what happens when you want to update it? Or, oh no, you have to roll back to an older version because something broke. How do you even know if it's healthy? You need monitoring. Suddenly, that nice clean model file becomes this complex operational beast.
So, how in the world do we tame that beast? Well, the answer lies with a really special class of tools, model-serving platforms. Think of them as the essential bridge that carries your model from the safety of the research lab out into reality. So what is a model-serving platform? It's a system built for one job and one job only, to wrap your model in a super high-performance, scalable, and manageable service. The two keywords you got to remember here are production grade and at scale. That's the whole game.
And this slide really shows you why they're so critical. Look, on one hand, you could try to build this yourself with something simple like Flask, but you're going to hit scaling limits fast, and you'll realize you have no easy way to version your models or monitor what's going on. A real serving platform, though, it gives you all of that right out of the box. We're talking auto-scaling, model registries, even advanced deployment strategies. It's what turns machine learning into serious enterprise-ready software.
Okay, so let's meet the main players in the space. We're going to go on a quick tour of 3 industry standards that you are absolutely going to run into: TensorFlow Serving, TorchServe, and the super flexible Seldon Core. First up, we've got TensorFlow Serving. And yeah, the name kind of gives it away. This is Google's high-performance system, built from the ground up to serve TensorFlow models in production. This thing is an absolute workhorse. It is just laser-focused on performance, giving you incredibly high throughput. It has model versioning baked right in, so you can safely switch between different model versions with zero downtime. Plus, it offers both standard REST endpoints for web stuff and gRPC, which is a super fast protocol that's perfect for low-latency internal services. It's designed to live inside Docker and Kubernetes, which makes it perfect for those big enterprise-scale deployments. Next on our tour is TorchServe. And you can probably guess, if TensorFlow Serving is the go-to for the TensorFlow world, TorchServe is its direct counterpart for PyTorch. It was actually built through a team-up between AWS and Facebook, specifically to create a smooth path to production for PyTorch models. Now, TorchServe really shines with features like batch inference. This is fantastic for efficiency. You can just group a bunch of requests together and process them all at once. It can also serve multiple different models from a single instance, which can save you a ton on infrastructure costs. And it comes with great logging and metrics right out of the box. Just like TF Serving, it's totally ready for Kubernetes and scaling up. And that brings us to our final stop, Seldon Core. Seldon takes a totally different approach. See, it's not tied to any single ML framework. It's designed to be a universal serving layer for any model, and it runs natively on Kubernetes. So, what's the big deal with Seldon? Well, in one word, flexibility. It just doesn't care if your model is TensorFlow, PyTorch, scikit-learn, it'll serve all of them. It's also truly Kubernetes native, which means it was designed from day one to use the full power of Kubernetes. And that deep integration is what lets it offer really advanced stuff like A/B testing and model explainability right out of the box. It's a true cornerstone of a modern MLOps stack.
All right, now that we've met them, let's put them side by side. This is where the differences really pop, and you can start to see which tool might be the right one for your project.
Okay, the most important thing is right there in that first row, framework support. TensorFlow Serving and TorchServe are specialists, right? Seldon Core is the generalist. It handles everything. And you have to notice that Kubernetes native checkbox. Being built for Kubernetes means Seldon just naturally uses its systems for scaling and management. And that, in turn, gives it that powerful built-in support for advanced things like A/B testing and explainability. So with all that info swirling around, how do you actually choose? Well, it really just comes down to your specific situation. Let's walk through a super simple decision guide.
This makes it pretty clear, doesn't it? If you live and breathe TensorFlow,
then TensorFlow Serving is your natural fit. If you're working with computer vision or NLP models in PyTorch, TorchServe is optimized just for you. But the second you have multiple model types or your whole infrastructure is already on Kubernetes, Selden Core just becomes the obvious, most powerful choice. And hey, for quick and dirty prototypes, don't forget that lighter tools like MLflow with Fast API can be a great place to start.
Okay, let's wrap this up with some essential wisdom. Following these best practices and avoiding some common pitfalls is going to be the difference between a successful deployment and a total production nightmare. Here is your checklist for success. Use Docker and Kubernetes. Use a model registry to track your models. Version everything, your models, your code, your data. Track your metrics. And probably the most important thing on this list, never fly blind. You have to always deploy with robust monitoring and logging so you know exactly what your model is doing in the real world.
And on the flip side, here's what not to do. Please, don't just wrap your model in a basic Flask app and call it production. Don't forget monitoring, don't forget scaling, and don't forget version control. And you absolutely must have a rollback strategy. Look, these aren't just suggestions. These are the essentials for reliable, production-grade machine learning.
And all of this really brings us to the core takeaway. I'll leave you with this thought. A model that lives only in a notebook is a piece of research. It's a fantastic accomplishment, but it's not a product yet. It's the serving platform that truly transforms that research into production, and that's where you create real-world value.